All right, let's suppose the graph looked like this. Suppose we have a graph and it looked like this. We have this parabola. Okay, so let's suppose we had this. All right, so when we talk about relative max, relative min, a relative max, relative min, when I read this graph from left to right, remember when we talked about increasing, decreasing? As I go from left to right, what are my y values doing here? Okay, so what are my y values doing? Increasing, and all of a sudden they're doing what? Decreasing. All right, and so we saw in the last class period how to write the interval for increasing, decreasing, and constant. All right, so that was the last class period. So look at the notes dealing with that. What I'm interested in here, though, is relative max, relative min. So when I go from increase to decrease, is this a max or a min? That's a max. So it's called a relative max, though, because we're looking at in this little area right here. It goes from increasing to decreasing, so it changes direction. This would be a relative max. Now there's something called an absolute max. We don't deal with that in here, but this happens to be the absolute max because this is the largest. This is the highest point. See the highest point? This highest point, right? All the other points are below it. Y'all see that? Okay, so that's an absolute max, but we're only interested in relative max, relative min. So the directions will say something like this. It'll say at what value or values, at what values of x is f of x a relative maximum. Okay? And then it'll say x equal blank. So if you look at that worksheet 2.2.1, it looks something like this. Then it'll say at what values of x, at what values of x, well, actually it'll say this, sorry, I'm going to rephrase it. And the relative maximum is, and the relative maximum is blank. All right, so go ahead and write that. So at what values of x, and that could be more than one. That could be more than one relative maximum. There could be more than one relative minimum. So at what values of x is f of x? Now f of x stands for what value? Y. So what values of x is y a relative maximum? And so what's that x value? And then the question is, what is the relative max? So the relative max is blank. Okay, so this right here, see this right here? That's called a relative what? Max. Okay, that's your relative max. It occurs at this point right here. Now, is there relative min? So relative min occurs when you go from decreasing to what? Increasing. So a relative max occurs when you go from increasing to what? Decreasing. And a relative min occurs when you go from decreasing to increasing. All right, so on this worksheet, for that one, is there a relative max? Is there a relative min? Okay. All right. On this one here, is there a relative max? Is there a relative min? No. Okay, so relative just means in a local interval. Okay, so this local interval right here. So if I look at just this interval right here, it goes from increasing to decreasing, and that's the maximum. All right, nice. Huh? I'm not going to ask it here. You would say there's none. Just say none. Okay, so there's relative max here, right? It helps if you label the point. What's this point here? 2, 4. So the point's 2, 4. And so that's going to give you your two answers. So I get a relative max when x is what? 2. And the question is, the relative max is, and when I say the relative max is, I'm talking about the y value. What is my y value? 4. So let's just put in those blanks. Okay? So you see how to do number 1. Now, in number 1, on the worksheet, now remember we said this was also an absolute because that is the highest point. Okay. So if I look at this one, and I'm making this up, it's not going to come out very well. Let's say I have this. Oops. I'm trying to get some nice numbers here. All right. So do the best you can with drawing this. Do the best you can with drawing this. Okay. So you see how the arrows keep on going up both sides? Y'all see that? All right. So my question is there an absolute max? No, there's no highest maximum because it keeps on going. There is no largest y value, right? Y'all agree there's no largest y value. You can't tell me what it is. It goes to infinity. So y'all agree there's no absolute max? Yes or no? Okay. So there's no absolute max. Is there an absolute minimum? Yes, there is a smallest y value. You can pinpoint it. What is the absolute smallest y value? Where does it occur? Very good, at -3. All right, but there is an absolute min. Right. Now, in this course, we're not talking about absolute, but I need you to understand the difference between absolute and relative. You're going to talk more about absolute when you get into either business calculus or science calculus. Okay, now, is there a relative max? How many? 1. Very good. Remember, relative max occurs when you go from increasing to what? Decreasing. Is there a relative min? How many? 2. Because there are 2 places where you go from decreasing to what? Increasing. All right. So a relative max occurs when you go from increasing to decreasing, right? And then the relative min occurs when you go from decreasing to increasing. Okay? All right, so let's do the same thing we did here. So at what value, could be more than 1, of x is f of x a relative max, relative min? And it'll say x equal blank, x equal blank. All right, that should be x equal blank, x equal blank, x equal blank. Well, that's not the question though. All right, so it says that what values of x is f of x a relative max? Is x equal what? 3. So 3 goes here. Then I'll say at what values of x is f of x a relative min? What goes here? No. There are 2 of them, right? -1 and what? 4. -1 comma 4. Now, on my math class, don't put it in parentheses. You put it in parentheses, it thinks it's a point. -1 and 4 is not a point. That's not an x and a y. They're both what? X's. So leave it like that. Remember, my math class just put them in comments. Yes. You're talking, no, you're trying to work ahead. You need to stop. Okay? You're trying to work that worksheet when we're doing this. You're not paying attention. So you need to stop. All right. Your question will be answered when we get to it. Okay, so what values of x is f of x a relative max or relative min? All right, and the question is, what is the relative what is the relative max and relative min. All right, so what is relative max, relative min? So when x is 3, what is that relative max? What is that y value? 5. So 5 goes here, y'all agree? Okay. For relative min, what is the relative min? Negative 3. See, it helps. It helps if you label this. So label this as negative 1, 3, and this is what? 4, 2, is that correct? And this is 3, 5. So the relative max, the smallest, relative min, the smallest y value occurs at what y value? Negative 3 and 2. So negative 3, comma 2. Okay? So that's what you would put here. Okay, and then let's see, suppose we had all right, now suppose we had this. Again, I'm making this up. Let me actually mess this up. Let me change this. Let me change that. Let's change it to this. This arrow here. Let's do this. Horizontal line. Let's do this. And this. Okay. So draw something like that. All right, so remember our relative max occurs when you go from increasing to what? Decreasing. Okay? That's how it changes. Go from increasing to decreasing. A relative min occurs when you go from so you can visualize a relative min occurs when you go from decreasing to what? Increasing. So how many relative max do you have here? There's just one. You go from increasing to what? There's only one place where you go from increasing to decreasing. That's this. So that's your relative max. Here you go from constant to increase. That's not increase to decrease. Here you go from increase to constant. That's not increase to decrease. Okay? What about what now? Say it again. That's an arrow. You read a graph from left to right. You read a graph from left to right. You go from decreasing to increasing. Okay? You read a graph from left to right. Okay? All right. So this right here is a relative what? Min. All right. So how many relative mins are there? How many relative max are there? Just one. Is there absolute max or min? No, because this arrow keeps on going up and this arrow keeps on going down. All right. So there's no absolute maximum value. There's no absolute minimum value because it just keeps on going to negative infinity, keeps on going to positive infinity. All right. But this right here, this point is going to be what? Negative 2, 1. And this is 3, 4. So the relative max occurs when x equals what? 3. And the relative max is 4. Okay? Relative min occurs when x equals what? Negative 2. And the relative min is blank. 1, right? Okay. All right. So any questions on that? All right. So that is worksheet part 1. Okay. Now on part 2, go ahead and take part 2 out. Okay. So here's the idea with part 2. Okay. So you have to listen to this carefully. Do any of you have the class notes from last, not the notes that I printed out, but the stuff like this that we were using last class period? Because I didn't use all of those graphs, I only used some of them. Y'all have it? Anyone has theirs? Let me see yours, Ashley. Yes, I think that may be it. There was another one. Is there another one? Well, that's the one she just started. Well, that's what she just gave me. Yeah. Okay. Take this one. Okay, so it's this one right here. I don't have any extra ones, but take this one out if you have it. If you don't have it, don't worry about it. It is posted on Canvas, though. All right, take that one out real quick. Take that one out. All right, what I'm interested in is this. Go to this one here. This one right here. You see how this graph here is continuous. See how this graph is continuous? As I go from left to right, I can take my pencil and trace over it like this. Let's see that. And if I look at this graph here is continuous as well. I can just trace over with my pen. You'll see it. All right, now I'm using the word continuous. Continuous. Whereas when I look at this one, I go here, trace over, and all of a sudden I've got to jump to go to the other one. Okay, that will be discontinuous. All right, we're about to graph something like this, but the ones we're going to do are going to be lines. So these are called step functions. Or let me rewrite it, rephrase it. Piecewise functions. Piecewise functions. So those are going to be called piecewise functions. There'll be pieces of parts of a whole graph, so to speak. Piecewise. All right, now for this one here, just out of curiosity from the graph, what is, and let's say this is f of x, what is f of, let's say, 4? Look at this graph. What's f of 4, do you think? Can you see it from there? Right here, right? Right here, right? So when x is 4, what's my y value? -1. Okay? What is f of -3? Oh, be careful, there is an f of -3. It's 0. That's this point right here, right? Okay? It's 0. So f of -3 is 0. Y'all agree, right? Because that's the point. That's -3, 0. This right here was 4, -1, correct? All right, what is f of -1? So remember how we do this. You remember this means what's the y value when x is what? -1. So x -1 here, if you look at the point of the graph, the question is what's that y value? So 3, y'all agree? Okay. What is f of 0? Remember that says find the y value when x is what? 0. So x is 0 on the y-axis. So what's that point though right here? That's 0, 4. So the y value is what? 4. Okay. All right. Now listen carefully. What is f of 1? Okay. Y'all agree f of 1 is 3, correct? All right. Now notice, and you're going to see this in a little while. Part of the graph is a closed circle, and the other part is what? Open. All right, so we talked about that in a previous lesson at some point. If it's closed, it's part of the graph, part of your domain. If it's open, it's not part of your domain. Okay? So parentheses, bracket kind of idea. Bracket, parentheses. Okay? So f of 1, we know it's going to be what? 3. All right, now, f of 2. When x is 2, what's my y value? That's the only point on the graph. You see it? But it's an open circle. So you would say does not exist, something like that. Does not exist. Okay? So there is no y value when x is what? 2. Because that's an open circle. It's not part of your domain. That's what that means. The open circle is not part of the domain. So if you were to write the domain, you would, for this little part of the graph, you would use parentheses. Remember, parentheses is not part of the domain. See how this is closed? You would use a bracket. All right, now let's talk about the domain. Let me just see if you can figure this out. We talked about this in the last class period. Domain and range. Let's do the domain and range. All right, domain's going to be a little easier than the range. So let's talk about the domain. So I'm going to use a ruler. And remember, for the domain, you go from left to right on the x-axis, correct? All right. So as you go, remember, this is a dot. That's where it starts. You can't see it, but your graph starts here. It has a closed circle. It starts here. So there's no arrow. It's not an arrow, meaning it keeps it going. Okay. It starts here. There's a dot. It's not a very good graph. You really can't tell very well. All right. So when I go from left to right, when do I start touching the graph? At -5, and it's part of the graph, right? Because it's a closed circle. So we bracket -5, comma, and then look, I'm going, and so on, right? And then all of a sudden, there's a gap. You see this gap between 1 and 2? Okay? So you're going from -5 to what x value? 1. It's closed, so it's going to be a what? Bracket. Union, because it's with 2 intervals. See how it's in different pieces? So 2 intervals. So union, and then you start back up when x is what? 2 with a what? Parentheses. So parentheses 2, comma, and then it stops when x is what? 5. Oh, bracket, right? Bracket, that's a bracket, not parentheses. Why is that a bracket? Right, closed circle. All right, see how the domain looks? So you see how it's broken into 2 pieces and there's a gap between 1 and 2? So you have 2 intervals. That's a bracket because that's a closed circle. That's a bracket because it's a closed circle. What now? Yeah, that's a closed circle. Remember, closed circle is bracket, open circle is what? Parentheses. All these should be brackets except for which one? Where the 2 is. Okay? Now the range, this makes a little bit more confusing because of how it looks when you go from bottom up. Okay, so the range is when you go from along your y-axis, but from bottom up. You go from smallest to largest. I start touching the graph when y is what? -2 is a closed circle, right? So we bracket -2, comma, all right? And then I keep on going. And remember, for this y value, I get a point of the graph. Just look what I'm doing. So this y value right here is that point of the graph. Okay, so keep on going, keep on going. For this y value here is that point of the graph. Yes, keep on going, keep on going. Now right here, this is where it's confusing. For this y value, is there a point on the graph? Yes, this one. That one. So my question is this. See, that's what the confusion is. So you got to be careful with this one. So my question is this. When y is 1, what is my x value? Whatever that x value is, but it's close to -2, right? All right? Yeah, and so you keep on going, get all these y values. Do you agree? And the largest y value I end up with is what? 4. So with the bracket, is there a more than one interval like there was for this one? No. All right, so the range is a little bit confusing, but think about the confusing part is here when you get to that open circle with your ruler. The y value of 1 is still part of the range because right here That's a closed circle right here. That's part of your graph. This is open. So all these points are part of your graph except for which one? That one, and all that one right here. But when y is 1, the thing you look at is this. You see open circles, you think you cannot include it, but you can include it because of this point here. That point, what is the y value? What is the y value for that point? 1. So 1 has to be in your range. Okay? So the range is a little bit confusing here, but just make sure you definitely understand the domain because that's what we're going to need in a little while. So make sure you understand the domain part. Okay. Yes. Say it again.
It would have to be broken like that in order to have two.
You're dealing with piecewise functions. You're dealing with two separate domains. You're going to see how it's going to look in a little while. Okay. So that was this. Okay. All right. Now, listen carefully. So this is going to help you with section 2.2, part 3. Section 2.2, part 3. Okay, so we're going to start looking at piecewise functions. And all we're interested in here in this course is linear functions. So you're going to be graphing lines in particular. And so it's going to look like this. So it's going to look almost, you see how when I drew the brace, it looked like a system I was dealing with? But it's not a system. You're graphing a piecewise function. So let's suppose my first one is this. So you're told f of x equals this. Say f of x equals this, right, like this. 2x minus 1 if x is less than 2. Write this out first so we can talk about it. Just go ahead and write it. And then x plus 1 if x is greater than or equal to 2. So go ahead and write it out. So that's a piecewise function. This function is made up of how many parts? 2. So it's made up as pieces. So these are called piecewise functions.
This is part 2. This is 2.2
Part
part 2.
2? Okay. Yeah, I have part 3 here. That's part 2. Okay. All right. So let's talk about this. Let's go ahead and find f of 3. All right, listen carefully. This says, what is the y value when x is what? 3. Okay, so remember a while ago we talked about the different domains? So this part right here is my domain. So if my domain is less than 2, which function do I use? The first one. If my domain is bigger than or equal to 2, which function do I use? The second one. Okay, so you're looking at different pieces with different domains. Okay? So that's what a piecewise function looks like. You're looking at two different functions, and they each have their own domains. And this right here should never overlap. Is that clear? Because it would no longer be a function. Do you see that these two things do not overlap? X is less than 2 is distinct from x is greater than or equal to 2. Okay? Y'all agree? All right. So if I want to know what's the y value when x is 3, that's what this means. What's the y value when x is 3? First of all, I've got to determine which domain is 3 in. The second one, use not the first one because is 3 less than 2? No. But 3 is what? Bigger than or equal to 2. All right, so you use the second one. So you use this function. Is that clear? And then remember how you found f of 3 before? Wherever you saw the x, would you plug in? 3. Okay, so watch carefully. So you're going to say x plus 1, but what's x this time? 3. So 3 plus 1 is what? 4. So in the blank, you're going to say f of 3 equals what? 4. Okay, that's what you're going to put in the blank. So remember what you found. You found that when x is 3, what's my y value? 4. That's what you found. So as an ordered pair, If we're about to graph something like this, but as an ordered pair, you would plug the point 3, comma what? 4. All right, what about this? Suppose you want to find, let's say this is A, let's do B here. Let's say B is F of 2. Now, don't let that confuse you. So which function am I going to use? The top or the bottom and why? The bottom. Why the bottom one? Because of the equal to. You're not going to use the top one because that says my values have to be less than 2. Well, 2 is not less than 2. 2 is what? Equal to 2. So I got to use the bottom one again, right? So where we see the variable x, what do I plug in? 2. I'm going to say 2 plus 1, which is what? 3. And then, so in the blank, you would say f of 2 equal what? 3. Okay? Y'all agree? All right? C. What about f of 0? Which one are you going to use? The first one. Because the first one is where you're using all numbers that are less than what? 2. Is 0 less than 2? Yes. So you use the first one. So you use the first function. Okay? So where we see the variable x, what do you plug in? 0. So 2 times 0 minus 1. What's 2 times 0? And 0 minus 1 is a negative 1. Y'all agree? So f of 0 equals what? Negative 1. Okay? What about D? Suppose we wanted to find f of negative 3. Which one do I use? Which one do I use? The first one, right? The first one. Because that's the one, because negative 3 is less than 2. Y'all agree? Okay, make sure you understand I use the first one. That's the easy part. This is easy to deal with. That's the easy kind. All right. So f of negative 3, you're going to say 2 times negative 3 minus 1. The order of operations, I multiply before I subtract. What's 2 times negative 3? And what's the negative 6 and the negative 1? So f of negative 3 equals a negative 7. Okay? All right. So that first part, y'all should be able to do those. The first part. You'll see it? The first one. The first page right here. Okay, let me just quickly do one like number 3, just to remind you what to do there. Okay, suppose we had this function. Let's make it g of x. G of x equal, and let's say my function g of x is made up of these two functions. X plus, let's say x squared plus 3 divided by x minus 1, and then x plus 2. Let's say this one's going to be, I'm going to use this one if x does not equal 1. I'm going to use this one if x equals 1. All right. Okay, so I just want to remind you about the domain part. Let's go back to this one. How many numbers are in this domain right here? How many x values are here? An infinite number. Because x is less than 2, there's an infinite number of real numbers less than 2. How many numbers are in this domain? An infinite number as well. Okay. How many x values are in this domain right here that I'm pointing? Just 1. This says x has to be only what? 1. If x is only 1, then I'm going to use what? This one. If x is any other number, then which one will I use? That one. Very good. That's how you read this. So this says that I use this if x is not equal 1. I use this if x does equal what? 1. All right, so watch how this goes. So A, find f of 2. Find f of 2. Which one do I use? The first one. Because this says I use this function if x is not equal 1. Well, does x equal 1? Here? No. X is what? 2. So I use the first one. So I get 2 squared plus 3 divided by 2 minus 1. Y'all agree with that? Wherever I saw the x, I plug in 2? Yes or no? Okay. Order of operations, 2 squared is 4. 4 plus 3 is what? 2 minus 1 is So that's just 7. So f of 2 is 7. F of 1. This says x equals 1, so which function must I use? The second one, because that's the one that says x equals 1. So I'm going to get x plus 2, what's x? Well, what's x though? 1. So 1 plus 2 is 3. So f of 1 is 3. Okay? F of negative 1. Which one do I use? Yeah, you're only going to use the second one if x is what? Any other x value, you have to use what? The top one. That's what that says. So I'm going to get negative 1 squared, x squared plus 3, divided by x minus 1. X is negative 1 minus 1. Order of operation, what's the negative 1 times itself? So 1 plus 3 is going to be what in the numerator? 4. What's the negative 1 and negative 1? So what's 4 divided by negative 2? So what is f of negative 1? Negative 2. All right, so f of negative 1 is negative 2. All right. So any questions on evaluating functions? The first page is not difficult. Y'all can do the first page, right? Okay. It's not that bad. Y'all can do this. All right. Now, let's start. The second page is where we start doing what? Graphing. All right, so let's do that. Okay, so you may, there's some grid paper up front. I think you picked up maybe 1 or 2 pages. So you may, if you want to use the grid paper as we do this, just go ahead and pick some up from the table. All right. The ones that you're going to deal with, if you notice, these are linear functions. These are linear. These are all linear functions. So you'll be drawing lines or segments or rays, combination of those. So I'm going to go back and I'm going to do the first one we did. See this right here? So let's go ahead and graph this one. So this is going to be, this one here, I'm going to say graph f of x equal this one here. So 2x minus 1 if x is less than 2. And then x plus 1 if x is greater than or equal to 2. Okay? All right, so here's the approach you would take with this. All right, you're going to use a t-table. And remember, these are lines. You just need 2 points to graph this. So first of all, we're going to graph the first function. So f of x equals 2x minus 1. But I got to keep in mind that I got to use values of x that are what? Less than 2. I got to keep that domain in my mind. Okay? So we're going to do a t-table. Now what is going to do? You must always use this number for one of your x values. And what number do you see here? 2. Even if there's no equal sign, you must always use that number. Because that says I can use any number up to what? 2. So I'm going to put a 2 here. Okay? And so I'm going to say my y value then will be 2 times 2 minus 1. See what I did? In place of x, what I plug in? 2. So 2 times 2 is 4. 4 minus 1 is 3. So I'll plot the point 2, 3. Okay? So remember, you must use this number as one of your x values. Now you may say, but there's no equal sign. It doesn't matter. You're going to see what we're going to do. There is no equal sign, I agree. But I still must use that number. Now, do you see how I got that 3? You better tell me now because we're going to keep on going. Okay, so you just plugged in wherever you saw the x value, we plugged in a 2. 2 times 2 is 4. 4 minus 1 is 3. All right, so when I plot that point, though, 2, 3, don't do anything just yet. Just watch what I'm doing. When I plot that point, there was no equal sign. So based on discussion a while ago, what will I use here? An open circle. You use an open circle. So at 2, 3, I'm going to use an open circle. So you put an open circle at 2, 3. Okay? And then all you do is just pick one more x value that's in this domain. Give me just one more. 1. Okay, fine, 1. When x is 1, I get y equals 2 times 1 minus 1. 2 minus 1 is what? 1. So I plot the point 1, 1, which is here. Now that's a closed circle, so you're going to put a dot. Because 1 is in the domain, right? And all you do is just take a ruler and you draw your ray. Now be careful. Common mistake people make is this. They do this. They draw a line like this. You don't do that. Because when you do that, you're saying that my x values for that first function goes beyond 2. Does it go beyond 2? No, it stops at 2. So you got to start here and do a what? Array. You remember what array looks like? You have one arrow and then an endpoint. So all I've done so far was graph which part of this piecewise function. All I've done so far was graph which part of that piecewise function. The first one. See what it looks like, right? Okay. Let's do the second one. So notice the steps we went through. Notice the steps. So f of x equals x plus 1. But I'm going to use this one if x is what? Greater equal to 2. Just like before, whatever number appeared here, I must start with it. So I must start with what? 2. Use a t-table. Remember, this is a line. These are linear, so you just need 2 points to draw a line, right? Just need 2 points. So what number must I use? 2. I must use 2. I must use this number. If x is 2, y equals x plus 1. What's x? 2. 2 plus 1 is 3. I did not mean to do that. It's okay. No, it's fine. It's fine. You would just you would just connect it. You would just put a closed circle here, but I didn't want to do that. Let's make this right here. I'm sorry. Excuse me. Let's make this a 2, x plus 2. Make that x plus 2. Because I did not want to do that to begin with. But if that were the case, you just close it up. You would just close it up. Okay? Just close it up. No. It'll be 4. Right? Okay. So I apologize for that. I did not mean to close it up just there. So when x is 2, I get y is 2 plus 2, which is what? 4. So I'll plot the point 2, 4. So 2, 4 is here. But do I use open or closed circle? Closed because of the what? Equal. Because of the equal. Huh? All right. And then to graph that point, I just need how many more points? 1. So give me a number that's in that domain. 3. I wouldn't use 5 because it will be beyond that grid. So use something that's inside that grid. So if x is 3, I get y equals 3 plus 2, which is what? 5. So I'll plot the point 3, 5, which is here. And then you just draw your ray. You must start here though, right? You're not going to extend it, correct? Because if you extend it, doesn't it automatically fail the vertical line test? And f of x are a function that's no longer a function, so don't extend it. It starts here. And there's your graph. Okay? There's your graph. Notice, make sure you put the arrows on these things like this. So if you remember how to graph lines from last semester, then you're just doing pieces of lines. So you're just doing rays in this case. Say it again? Okay. All right. Okay, let's look at this. Suppose f of x is x minus 1 if x is greater than negative 2. I'm making this up. And then 4 if x is less than or equal to negative 2. Okay, go ahead and draw that. Write that one. F of x is 4 if x is less than or equal to negative 2. All right, so you got to remember something from a previous course, though. So in a previous course, if I ask you to graph y equals 3, and you had this on your final last semester, it was math 98. So math 98, you had something like this: y equals 3. So it's 2 semesters ago. What does that look like? Y equals 3. Not a vertical line. It's a horizontal line. Y equals 3 is a horizontal line because remember, that means this, in terms of the t-table, that means that my y value always equals what? 3. So all along this y column, I'm going to have a what? 3. No matter what x is. So if x is 0, what's my y value? If x is 2, what's my y value? And so on, right? So when I graph this, 0, 3 is here, 2, 3 is here, and what do you notice I get? Yeah, they're all straight lines, but in particular, I get a horizontal line, right? So y equals 3 is a horizontal line. Because it's a horizontal line. Oh. All right, and then the other one you graphed a couple semesters ago was this, x equal, let's say, 1. What kind of line is that? It's a vertical line. So that says that x must always equal what? 1. So along the x column, what do you see? Because that's what that says, right? No matter what x is. So when I plot those points, 1, 2, 1, 3, and draw the line, what kind of line do you get? It's a vertical line. So what we're about to do, if you notice, y equals what? 4. So when I graph this would be what kind of ray? A horizontal ray. Okay? So you have to remember some things from previous courses. They all tie in together. They all tie in together. Okay, let's go back to this. So graph each one individually. So let's do the first one. F of x equals x minus 1. And I got to use this if x is what? Okay, so when I do a t-table, what number must I use first? Negative 2. So then I plug in negative 2 into my function. So y equals negative 2 minus 1. Y'all see where I got negative 2 minus 1? Because x is what? No, x is what? Negative 2 minus 1, and what does that equal? Negative 3. So when I plot that point, negative 2, negative 3, is that an open or closed circle? It's open, because there's no equal sign, right? Negative 2, negative 3. Now I need one more point to draw this ray. Give me another number that's in this domain. Give me one more number. Huh? Negative 1? Okay. You could have said 0. You could have said any number bigger than any positive number, right? You could have said 1. You could have said 2, and so on. 2.7, whatever you wanted to. But you said negative 1. So y'all agree that negative 1 is bigger than negative 2? Okay. So y equals x minus 1. Negative 1 minus 1 is a what? Negative 2. So I plot the point negative 1, negative 2, which is here. So I put this little dot. And then what do I do next? Draw the ray. So I want you to use that word ray. Don't say draw the line, because when you think about drawing the line, what you can do is draw a line like this with arrows on both ends. Is that the case? No. You're going to start here from high school geometry. You're going to draw a ray. Just like that. Okay? All right, now let's look at the next one. So the next one says f of x equals what? 4. Now remember, that's f of x means the same thing as y, right? And I'm going to, and my domain for this one is when x is what? less than or equal to negative 2. So I do a t-table. Now, what x value must I use? Negative 2. That's a closed circle. So there's equal signs. I'm going to use a closed circle for that one, right? Okay. So when x is negative 2, now don't let that confuse you. Think about this t-table I did earlier with y equals 3. So this says y is always going to equal what? No, but here, 3. This says that y must always equal what? 4. So if x is negative 2, I don't care what x is. Y is going to equal what? 4. There's nothing to plug in. That says y equals what? 4. Now, you got to give me one more number, though, that's in this domain. Negative what? 4. Okay. When x is negative 4, what is my y value? 4. That's what we just talked about. Your y values must always equal what? 4, no matter what your x is. Okay? All right. So to have done that one, you had to remember this from a couple of semesters ago, how to graph these, how to graph horizontal and vertical lines. No, it'll be array. They're all arrays. Well, you start where? It helps if you plot the points, right? It helps you plot the points. So negative 2, negative 4 is this closed circle right here. Y'all agree? And then what's the other point? Negative 4? That should be, I'm sorry. Shoot. Negative 4, excuse me. Negative 4 is here. Y'all agree? Y'all agree? All right. Negative 4 is here. Y'all agree? No? All right. And then you draw your ray. Where do you start? Start here. This is where you start and you connect the dots, right? You're not going to go this way because this says my x's have to be less than what? Less than or equal to negative 2, right? So here's, make sure you see this, guys. Here's x negative 2 right here, right? I got to use x's that are what? Less than that. So aren't you going to the left? If you started here, went to the right, would you be connecting these dots right here? No. All right. So there's your graph. Any questions on that? Okay. All right. So in terms of that worksheet, that should be able to do these two now. Now there's a video on this when you go to Canvas. So if you need to look at it a little bit more, look at it a little bit more. But you can now do these. Okay. All right. So everybody okay with 2.2 part 2? All right. So that takes care of piecewise functions. Okay, now you're not going to like what I'm about to tell you. So look at worksheet part the part 3. Look at part 3. You're not. Okay, so for this one, here's what I need you to do. And not yet. Hold on. Okay, so we talked about piecewise function and how to graph it. So that's video 2. Okay, we will not have time to discuss in class how to algebraically determine if a graph or equation is symmetric to the x-axis, y-axis, or the origin. So you will need to view the videos on this, and it's just video 3. Now, that will not be in a test, but I did put on a worksheet. I still need for you to understand how to determine that. So I need you to look at the video. While you're doing the video, you work on the worksheet. It's not going to be on a test, on the final, or the final. That's video 3. Y'all see where it says on this, right? Okay. So you go to that section, look at video 3 to do worksheet part 3. Now, remember, some of you probably say, well, I'm not going to worry about it. Well, you really do, because that's going to help you at some point. I'm not going to ask it on a test or a final to algebraically determine it, but the idea behind it can help you. So So I don't have time to do this. There's a video on it, so I need for you to watch it. And the same thing for even and odd. So these two right here, and that's this whole worksheet. So the first one talks about. So I'm telling you that this is symmetric with respect to the origin. I need for you to show me that it is algebraically. So look at the video. The video tells you what to do. This right here says I don't know why it's blurry. This right here. Can y'all read that? Yeah, I can't. I don't know what to do with this. So no, it's not going to do any good. These Elmos, I don't even know if they make Elmos anymore, but we still have an Elmo from 10 years ago. So here I need you to determine if that function is even or neither, and then the video tells you how to do that, and that's going to be video number 4. So video 4. So some of you may say I don't want to do it. I'll just get a 0 on it. It'll drop it anyway. But I don't want you to do that. I need for you to do that worksheet. And so you come at 6 o'clock next week and you ask questions about it. You need to, I know, but you need to try and do it. You need to try and do it. Okay. So attempt. I really need you to attempt this. Attempt to do part 3. Okay. Now look at part 4. We've already talked about part 4. So increasing, decreasing constant, right? State the domain and range. Find f of 3. We talked about relative, max, or min. You all agree? Okay. Now, right here, it says, is f of x even, odd, or neither? Okay. Now, it didn't say anything about algebraically. But here's the idea in terms of a graph. Okay, so I'm going to just say this in terms of a graph. Listen carefully. A function is even. A function is even if it is symmetric about the y-axis. A function is even. A function is even if it is symmetric about the y-axis. A function is odd if it is symmetric about the origin. So a function is even if it's symmetric about the y-axis. A function is odd if it's symmetric about the origin. All right, here's an example of a graph of a function that's even. Make sure you see why. You see why this is even? Okay. So remember, a function is even if symmetric about the y-axis. So if I take this part of the graph and reflect it about the y-axis, don't I get this part back? Okay, y'all see that, right? If I take this part of the graph and reflect it about the y-axis, do I get this part back? Yes. So that's what even means. Okay? So what if you had this absolute value? You graph absolute values last semester. In Math 99, you did graph those. Is that an even function, yes or no? Yes. Because it's symmetrical about which axis? The y-axis. So this is even. This is even. Okay? What about this? No. That graph is not symmetrical about the y-axis. If you take this part here reflected about the y-axis, there's no way you can get this part back, right? Okay? So you would say neither. Well, let's put not even. So it's not even. Okay? So even is easy to visualize. You can see it If a function is even, you can easily see it. Let's talk about if function's odd. Draw something like this. Draw something like this for right now. Draw this. I'm telling you now this function is odd. That's an odd function. All right? And remember, an odd function is a function that's symmetric about the what? The origin. An odd function is symmetrical about the origin. So when you look at the video about the algebraic, you're gonna see how it relates in terms of the origin, the algebraic part. But look, this is what you do. You take this point here, watch, you take this point here, or any point, doesn't matter. Just pick a point here. Draw a line through the origin like this. See that distance here? Keep going, and it's going to get to this point. So you can get another point on that graph. So this point, now remember, when we did even, remember we used the word reflect? We use the word reflect, right? Okay. So you use the word reflect again. Watch. This point here, I reflected about the origin. I reflected about the origin. See how I'm reflecting it? So think about this distance here. This distance, keep on going this way. Do you agree that this point, when I reflect about the origin, becomes that point? Yes or no? All right, visualize it. This point, when I reflected about the origin, I get that point. This point here, when I reflected about the origin, I'm going to get this point. Y'all agree? Because this distance, look at that distance. That distance is the same as that distance. Okay, so you see how to determine if a graph is symmetrical about the origin? Just kind of look at those distances. This distance and this distance, do you get the same point? Do you get a point in the graph? From here to here, do I get a point in the graph? And yes, I do. Okay, so that's an odd function. So when you look at this, you know automatically what to say here. It's neither. It's not even. That stuff is not symmetric about the y-axis. It's not odd because when you look at this point here and reflect it about the origin, you get a point down here. Is that point on the graph? No. Pick a point here reflected about the origin, you get the point here. That's not on the graph either. So what would you say here? Neither. Okay. All right, now look at this one. Is this function even? Okay, so look at this part here, right here. Okay, if I reflect this about the y-axis, I get this right here. Y'all see it? Is that on the graph? No. So is it even? No. And again, if I take this piece here, just look at it. If I take this piece and reflect the whole thing, kind of like folding it about the y-axis, you're going to get this piece here. Y'all see that? Y'all see it? All right. So do I get something like that? No. Okay. So watch. If you get this, I'm going to draw this part of the graph right here. Let's say I had this, and let's say I wanted to make this an even function. I would have to take this and reflect it, right? So I would get something that looks like this. That would make it what? Even. So if I fold it, then it would be even. Does that look? Does that part here look anything like this? No. So it's not even. Okay, now let's talk about odd. The best thing to do with odd is pick a point and draw your line. So if I, let's say, pick this point here and use a ruler to help you. So if I pick that point here and go through the origin like this, okay, the same distance, go through it. Does it look like this is it right here? Yes. All right, if I pick this point up here, look, this point here, go through the origin, the same distance, you get this point right here. Yes. So this is what kind of function? Odd. That would be an odd function. See how it looks? So I'm telling you the answer for these. But make sure you go back and understand why it's like that. Yeah, now something like this. Now her question is, remember I said this about the test. I said I'm not going to ask you to determine algebraically if a function's even, odd, or whatever symmetry. But I can ask you from a graph whether it's even, odd, or neither. Okay? Yes, look at it and visually determine. Yes. Okay? What was your question? No. Okay? All right, so go ahead and take a real quick break, 5 minutes.